Hello and welcome to the review video for the springs and work test. The following topics include springs, mostly the spring force, finding the spring constant on a graph using the slope, work in one dimension so you don't have to worry about finding work in the two dimensions. There's power, and also knowing how to find work on a graph by using the area under the curve. There are about 34 questions in this sheet. Most of them follow the same procedure, so I may just break this up into 2 videos instead of 3. So let's start with the first question. Okay, so we have a vertical spring. I'm going to draw the spring right here to show it in its original state, where it's 0.1 meters long. And then it's going to go like this to .119 meters when you attach a mass at the end of it. And this mass is 1 kilograms. Okay, so first we're going to do a little bit of force analysis here. Let's do a different color. Alright, so when you hang a mass from the bottom of a spring, you're going to have the force of gravity pulling down on the spring. As a result, the spring force is going to go back up. Therefore, F of G is equal to F of S. Okay, so finding that F of G, we're going to do mass times G. When you put in those numbers, it's going to be 1 kilogram times 9.8 meters per second squared. Which means that the force of gravity, which is also the spring force, is equal to 9.8 newtons. Okay, that's the first step. Next, we gotta find what x is, because we see a stretch from hanging the mass. Okay, so x, we're gonna take 0.119 minus 0.1, and we're gonna get 0.019 meters. Then we're going to plug this into our f of x equation. F of s, my mistake. F of s is equal to k times x. We're solving for the spring constant k. So when we plug it in, 9.8 newtons is equal to k times our x of 0.019 meters. Divide those numbers, and k is approximately 520 newtons per meter, and that is our answer. Okay, choice D. Okay, so number 2 gives us a graph, and it's asking for the spring constant. When you have a force and elongation graph, the slope of the line will give us the spring constant. So how do we find the slope? Okay, so k is equal to, the formula for slope is delta y over delta x, or rise over run. So we're going to take 2 points on the graph. Let's pick these two. Simple. And so the change in y is from 4 to 0. Let's look over here, from 4 to 0. Okay. So 4.0 minus 0 over the change in x is from 0.2 to 0. And so k is equal to 4 divided by 0.2, which is the same as 4 times 5, and that's equal to 20 newtons per meter. Okay, choice A. Okay, so number 3 is the same thing. We have another graph, but you want to be careful here because the axes are switched. So if you look here, force is on the x and elongation is on the y. Normally we have them switched, so what we got to do is to write or alter our formula. But first things first, we got to select our points to find a slope. Then we're going to write our formula. It's going to be the reverse, where we're going to do delta x over delta y. Not exactly the slope formula, but you get the picture. All we need is really the force over the elongation. Okay, so we're going to have 1 minus 0 over 0.1 minus 0. And that's going to give us 1 divided by 0.1, and that's the same as 1 times 10, which is equal to 10 newtons per meter. Okay, looking at our choices here, you want to be careful. What we need is a unit in newtons per meter, because that's precisely the units for spring constant, and pick the number 10, so that is choice D. Okay, number 4, another spring question. Gave us the K constant of 100 newtons per meter. Look out for the units. Newtons per meter is the unit for a spring constant. Object is attached from the bottom. Spring stretches from 0.5 to 0.65, so we're going to take the difference of those two. And that's going to equal 0.15 meters. And we're looking for the weight, which is the same as the spring force. Okay, so f of s is equal to kx, which is equal to 100 times 0.15 meters, and that is going to give us 15 newtons. Okay, so that's choice B. Number 5, it's a work question. So here's 60 joules of work and 5 meters long of a ramp. And we're looking for the force. So the equation for work is equal to force times distance. They gave us the work, 60 joules, and they gave us the distance, which is 5 meters. And we're looking for force. Plugging those in. Force is equal to 12 newtons. 60 divided by 5 gets you 12 newtons. 6 is asking for the spring constant. So once again, we're going to use the spring force formula. They gave us the force, which is the weight of the object, because we have a vertical spring. So Fg is equal to Fs, which is equal to 20 newtons. We have our x. It goes from 0.5 to 1 meter, so 1 meter minus 0.5 equals 0.5 meters. Okay. Then we're going to plug it in. And K is equal to 40 newtons per meter. Choice D. Okay, 7 is another diagram, but this time they gave us the x. They gave us the weight, which is the spring force, and we gotta solve for K again. Oops, that looks ugly. There we go. What's our equation? Fs is equal to Kx. Plug it in. K is approximately 67 newtons per meter. Choice B. 8 is a work question. We have the force and a distance. Work is equal to force times distance, so we could easily find the work. Taking those two numbers, 9.8 times 10 to the 2 is the same as 980, I believe. Yep. Times 10 meters, which is equal to this number, 9,800 joules. So that's 9 times 9.8 times 10 to the third. Okay. Then number 9 is another work question. Same equation. Our force is 20. Oh no. Careful, guys. Don't want to get that confused. So here we have a cart that's weighing 20 newtons and it's pushed 10 meters. So there we have our distance on a level surface by a force of 5 newtons. So there. When you're given two forces, you want to pick the one that does the work, the one that causes displacement. So that force of 5 newtons is the force for our work. Okay, so 5 newtons times 10 meters is equal to 50 joules. This looks like a familiar example. I'm pretty sure we did this in class. 10, another spring question. So we have a force of 6 newtons. We have our compression distance. And we're looking for the spring constant. So that means, oh, look here, it's a short answer question. That means we gotta show our work. So how would you go about doing this then? First, let's start off with the equation. F of s is equal to kx. Our spring force is equal to 6 newtons. K is what we're solving for, and our x distance is 0.04 meters. 6 divided by 0.04 gets you 150. What's the units for K? Newtons per meter, and that is it. So for number 10, K is equal to 150 newtons per meter. Okay, 11. Work. We're looking for work. Let's put a line to separate. Okay. So you want to be careful here because we have two different forces, two different weights, the weight of the girl and the weight of the box. So which object is the one that's getting the work done is the 10 Newton box. So that you're going to use as your force. And the distance here is 0.5 meters. Ooh, two different colors. Let's do our answer in a third color. So 10 times 0.5 is 5 joules. There we go. Choice A. 12 is a bit of a trick question. We want to find a combination of units that can be used to express work. We normally use the unit of joules, but what exactly can joules be broken down into? So let's look at the work equation. Force times distance. The units for force is newtons, and the unit for distance is meters, so which is all equal to joules. So looking at our choices, the only answer that fits is choice D. Okay, now we're up to number 13. We have a 20 Newton force being used to push a cart a distance of 5 meters. We're looking for the work. The force we use is the 20 Newton force. We just ignore that mass. We don't need it. And so when we plug it in, 20 newtons times our distance of 5 meters. 20 times 5 is 100 joules. Okay, so I want you to be careful with number 14 here. So we have a student doing 300 joules of work going 3 meters east, and then 400 joules of work going 4 meters north. So we're looking for the total amount of work done. So the tendency might be to think of it as a Pythagorean triangle, where we have 300 joules on 3 meters east, and then we have 4 meters with 400 joules. Or we have the hypotenuse, probably our answer, 5 meters, 500 joules. Choice B has that answered, but it's wrong. We're not going to do that. Really, the thing about work, it's not like displacement. It uses distance where it's path dependent. So what we're going to do here is just add 300 and 400. Total work is equal to 300 plus 400, which is equal to 700 joules. Choice C. Simple as that. 15 is rather unique because we're given a mass and a distance. If we look at our mass here, it's being raised vertically. So typically the force done here when you're raising objects vertically is the same as its weight. So we're going to take 2 kilograms times 9.8, and that is going to equal 19.6 newtons. So there we have our force, which we can use to find work. Okay, so 17, the key word here for work being done is that force and displacement must be in the same direction. That means horizontal, horizontal, vertical, vertical, or both at an angle in the same angle. Okay, so looking at our choices, let's cross them off each one by one. So A is wrong. B, is there any displacement? Nope. C, looks good, but let's check out D. Person standing is not moving at all. Okay, so it's choice C.